Okay, so continuing with our complex number stuff. We ended the first day talking about multiplying. What if you multiply these two? Notice they're the same in each parenthesis except for one's a plus and one's a minus. If you multiply them together, you would get 9 minus 6i plus 6i minus 4i squared. So look at the middle here. Negative 6i plus 6i cancels out. And I squared, remember, is negative 1. So that becomes 9 plus 4, which means the answer to this is 13, which is kind of cool. When you take a plus bi times a minus bi, those have a special name for them. They're called complex conjugates. Why can't I get this to move? Good grief. They're called complex conjugates because when you multiply them together, you'll always cancels out. So that becomes really important when we simplify with complex numbers, okay? Because the one thing I didn't show you is that with square roots, we want to, with fractions, we, just like square roots, we don't like square roots in the bottom of our fraction. We also don't like imaginary numbers in the bottom of our fraction. So if I ask you to simplify something like this, you have to know that means I want to move the I from the bottom to the top. Well, you might say, well, let's just multiply by I. But if you do that, the I just moves to the 3. So the only way to cancel it out is to know to multiply by the conjugate. So what I'm going to do is I'm going to multiply by the conjugate of 3 plus 2i is 3 minus 2i. But I can't just do that on the denominator. I also have to do that in the numerator because then that is just like multiplying by 1, right? So the numerator, I just take 5i times 3, which is 15i. Then I take 5i minus 2i, which is negative 10i squared. And on the bottom, what should happen is everything should cancel out. So 3 times 3 is 9. 3 times negative 2i is negative 6i. That's plus 6i. And that's minus 4i squared. If you have an I left in your denominator, then you know you did something wrong. So the last step here is just to simplify. Well, this is negative 10 times negative 1. So that's 15i plus 10. And on the bottom here, just like we just did, this becomes plus 4, because negative 4 times negative 1. So we get 15i plus 10 over 13, which I'm fine with this answer. But you can also break it up like as the real and the imaginary part. If you want to break it up as the two fractions, right? Some people put the I here. Some books put the I out here. It's kind of up to you. But just like other things, you can leave it all as one fraction, or you can break it up. So I think I have one more of those. So what would you multiply on this one? Well, it's all about the denominator. So 1 plus I, you're going to multiply by 1 plus 4i, you're going to multiply by 1 minus 4i. You only change the middle one. So now on the top, this one's a little bit more work than the last one, right? You need to FOIL this out. So on the top, 3 times 1 is 3. 3 times negative 4i is negative 12i. I times 1 is plus I. And I times negative 4i is negative 4i squared. On the bottom, every time I know the middle term is going to cancel out, so I don't always do that, but I will for you. So that's 1, and then I get minus 4i. I get plus 4i. And then 4i times negative 4i is negative 16i squared. And every time that middle part should cancel out. So I tend to do the bottom first because it works out nicer. That's minus 16 times negative 1, or that's 1 plus 16, which is 17. On the top, this is negative 4 times negative 1 here. which is plus 4. So 3 plus 4 is 7. And then negative 12i plus 1i would be negative 11i. And again, you can leave your answer like that, or you can break it up as the real part, 7 over 17 minus 11 over 17i, and the imaginary part. So that's the last step with simplifying with imaginary numbers. So why do we have imaginary numbers thrown in this quadratic section? Because now we can solve equations that have imaginary solutions, meaning up to this point, you have said this has no real solution, but now we can actually solve them, okay? So if I say solve this, just like we've done before, if it's factorable, I look at it and I say, well, let's see if I can make my parentheses and say what multiplies to give me x squared, x and x. What multiplies to give me 8, that adds to give me negative 4. Oh my gosh, we don't know, right? What's 8 and 1? 6, 4 and 4. Nothing else multiplies, right? So up to this point, we would have said that this is prime, right? Well, what this means now is that we can solve them that have imaginary solutions. Gosh, we haven't talked about the quadratic formula yet, yeah, we're going to say, we're not going to do this one yet because we haven't learned that yet, but we're going to do stuff like this, okay? What am I? Okay. We're changing this, okay? That is have imaginary solutions, but I haven't reviewed the quadratic formula with you yet or completing the square, so I got to make this up, okay? So what if I said this? X squared plus 144 equals 0. Up until now, we haven't been able to solve this because this is not a difference of two squares. But now we can. Now I can say, if I subtract that over, that would be x squared equals negative 144. And I could take the square root of both sides, and I could get that x equals plus or minus 12i. Which means if I graph this, it never crosses the x-axis. But what it does have is it has two complex solutions, or two complex zeros. So, same thing with this one. Let's cross this out. And what if I said x squared plus 64 equals 0? How would I solve that? Well, I could subtract 64 over. I could take the square root of both sides, and I could get x equals plus or minus 8i. The only thing more complex that this can get is what if I said this? X squared plus 8 equals 0. Well, I can subtract 8. And then I can take the square root of both sides, but I want you to simplify that. So that would be plus or minus. What could we break this up as? Well, we could take out a 4 and the negative 1, but we would also be left with a 2. So my exact answer would be 2i radical 2. And that's kind of where we're going to end before our next test. So you can tell how many zeros you're going to have by looking at, oh, wait, we're not going to talk about this yet because we haven't talked about the discriminant. Oh, my gosh. What notes am I using is the real question.